Hey everyone, I'm Nick, and this is my gasoline and diesel fuel discussion. There are several ways gasoline and diesel fuel fires can start, one of them being during a vehicle collision. The most common cause for vehicle fires are due to defective fuel tanks. Issues with your fuel lines can also be another major problem because if it can rupture during an accident. Gasoline can be highly flammable and can ignite with a simple spark. This fluid can easily catch fire in the engine compartment because this compartment usually has hot metal or plastic parts to it that can cause a fire. Diesel can also be another hazardous material because of its vapors. If temperature increases, its vaporization rate will also increase, which then enhances the risk of a fire happening. Besides these fuels, it's also good to remember that there are other dangerous fluids in a car engine. This includes engine oil, transmission fluid, power steering fluid, and engine coolant. Car fluids are known to have corrosive, poisonous, and flammable properties to it, gasoline being the worst of them all. So a few years I've been a firefighter. My encounters with gasoline and diesel fuel fires have been mostly with vehicle fires. I believe these are one of the most dangerous calls we had to respond to, not just because of the hazardous materials involved, but the fact that we have to respond to these calls in a major highway or a streetway, which is either busy with a lot of traffic. That's why we park our apparatus a certain way and we wear high visibility clothing. This is to protect us from oncoming traffic. When approaching these type of fires, we always have to consider if there's life involved, and then we evaluate the possible exposures around it. In Sonoma County, it's a very rural area, and we have a lot of dry grass that can easily catch fire because of these type of fuel sources. Very common for a vehicle fire call to be combined into a vegetation fire call also. And it's happened numerous times in our area. Once the size up is performed, we don our SCBA and equipment on, and we start our extinguisher process. So it's preferred that we use Class B foam in these type of fires. However, most departments in our area only carry Class A foam. In most cases, though, water is going to be our most common method to extinguish these type of fires. This can be complex sometimes if there are two hose lines deployed into the vehicle. The reason for this is because of the properties involved. Water has molecules that are polar, while gasoline has molecules that are nonpolar. This causes these molecules to repel from each other. Depending on where these hose lines are positioned, they can possibly push the fuel and fire towards each other if they aren't careful or aware of what's going on. That's why these type of attacks must be coordinated. The amount of water being displaced into the fuel can also be another factor. If the hose line only produces a small amount of water, this can just cause the fire to spread somewhere else. However, if you deluge it with a significant amount of water, eventually it will smother the fire. So now let's look more into the components of gasoline and diesel fuels. Gasoline is a Class 1A fluid. These type of liquids usually contain butyl alcohol, styrene, and turpentine. The flash point of gasoline is between -40 to -50 degrees Fahrenheit. Its boiling point will vary from 100 to 400 degrees Fahrenheit. Specific gravity for gasoline will be 0.7013 in natural gasoline and 0.739 in vehicle gasoline. In regard to diesel, it is classified as a Class 2 liquid with a flash point range of 350 to 625 degrees Fahrenheit. It has an auto ignition temperature range of 350 to 625 degrees Fahrenheit. Its boiling point can vary from 150 to 380 degrees Celsius. Lastly, diesel fuels will have a specific gravity of 0.82 to 0.95. Knowing this information of gasoline and diesel fuel fires will help prepare firefighters know how to approach these type of hazardous materials. Thank you for listening. Have a great day.